All right, this is section 5.4 continued. We're going to introduce the point slope form, and we're going to find out where I have a huge difference of opinion with your author. I do not believe in finding the equation of a line using the slope-intercept form unless the y-intercept is given. If you are not given the y-intercept, I do not want to see you use the slope-intercept form 2 times in order to find the equation as your author describes. This is the purpose of the point slope form of a line. It is very good at its job, and therefore we should take advantage of it. If we are not given a y-intercept, this is when we use the point slope. So here we go. Point slope form. These are the scenarios we're going to see again. You're given a point, the slope, and a point that is not the y-intercept. We're given 2 points, neither of which is the y-intercept, or given a graph and the y-intercept isn't an integer ordered pair and there's no guessing. So here's the point slope form. It looks like, it's kind of messy looking, and I know it can be confusing, but it is doable. Y minus y sub 1 is equal to m times x minus x sub 1. Now the x and the y that don't have subscripts, those are the variables. The m is the slope, and x sub 1, y sub 1 comes from an ordered pair. So what we're going to do is we're going to plug in for this x sub 1 and y sub 1. Now students always tell me that's really complicated formula and I can't remember how it goes. Well, first of all, I give you a cheat sheet on your tests, and so there should be no reason that you can't remember it because you have that formula written down on your cheat sheet. And the second thing is that this is nothing more than the slope formula. If you solve this for m, in other words, divide both sides by this x minus x1, you see y minus y1 over x minus x1. So it's just the slope formula. So you should be able to remember that. And then the other thing that students say, well, okay, I can get that. Yeah, you're right, but I don't remember which one to plug in for. Well, really it will work with both, plugging in either here and here or here and here as long as you're consistent. But it's really much easier if you remember, I can't change the slope. So when I go to distribute this m across here, when I multiply this m times this x, it won't change the slope. So I can't plug in a value for the first x, it has to be for the second x because I don't want to change my slope. So with that all said, let's go ahead and see it used. So example number 19, let me scroll it a little bit there. We have negative 2, 5, which is a point, not the y-intercept point because it doesn't have the x being equal to 0 right here. That's how we tell that this is not the y-intercept. X does not equal 0. So this thing is not equal to 0, and therefore we know it's not the y-intercept. And we're given the slope. So we're going to say y minus whatever our y1 is, and that's a 5, is equal to whatever my slope is, that's a negative 1, times x minus whatever my x1 is, and my x1 is a negative 2, and so I'll put that in just like that. And I'm going to bump these up to brackets so that we can tell more easily. So y minus 5 is equal to negative 1 times x, which is a negative x, and then negative times a negative times a negative, which is a negative 2. And then finally, one last step here, we add 5 to both sides, and we're going to finish off our equation. Y equals negative x plus 3. I always want you to finish in slope-intercept form. I'm different than a lot of books / authors on that one, but I'll always want you to finish in slope-intercept form. Now you'll see once you plug into the point slope form here, it's a very easy process that goes the exact same way every single time. You're going to distribute the slope through, and then you're going to move the constant over to the right side. Now you might want to try on your very own here with part B. Now part B is going to have a fraction in it. Don't freak out. You can do fractions, and then you can come back in the next lecture and see if you got it correct.